Hi, Henry Tribble here for the M.I.A. devlog production. Devlog production. It's been a long day. So, in this video, we're just going to go over some of the shaders I used and some of the shader code within that. Starting off with the acid shader. Um, so, it has a little bit of specular, and essentially all it is a water shader, but colored green. It's got a little bit of depth. Basically, the way this works is it takes two normal maps of waves. So, if you didn't know what a normal map is, if there's a good way of explaining it. So, if I open up Blender here, Blender's a 3D modeling software that's pretty useful. It's what I use for all of the models in that game. Everything in that game is made by me. If it isn't, there's documentation saying it isn't. But like 99.9% of it is made by me and my team. So these blue lines are normals, and it's essentially, if you see the face, it is perpendicular to the face. So if I rotate the face, it's always going to stick directly out that face, and also all of these faces. So what a normal map does uh, is it essentially adds loads and loads and loads of these different little arrows for each pixel um, to basically change how the object is shaded. Because this object is shaded by taking that normal and performing some dot product maths to determine how much shadow is on that face. So if I were to like move it and then render it, let's say in like a quick light source to show off. So that, and you get a little bit of fun. I think it's called Peter panning on the side because of Eevee. There you go. So yeah, if I move it, it's all this face is in like direct sunlight. This face is at a harsher angle, and these phases are completely opposed from the sunlight. So if I could take this and move it like this, and now that normal is completely different. So if I were to apply a normal map to this, um, let's start with a new. Actually, let's so the normal map doesn't change the geometry at all. It just takes it all it does is add normal maps. So I'm actually going to take the normal map, the wave normal map I had, um, and apply it onto that cube just for curiosity. Uh, just real quick. So now, once I've done this, you can see that this cube, whilst still being definitely a cube, you can see how the shading changes depending on the light. So basically what I've done to this face is before where I had that uh normal of where is it gone? A normal like that. I've now for each one of those lines I've gone and added loads and loads and loads in. So you can see how the shade works, and it kind of looks more like we can do it like this. Like boom boom boom. So instead of that one line, there's loads and loads and loads of lines pointing in different directions. So light bounces off it differently and causes these weird, funky reflections. So it can add a lot of detail to something that is all in all not that complex. And that's essentially what we're doing. Uh, Oh, I can actually show. That's essentially what we're doing with this water texture. We're taking this normal map and we're taking this other normal map and we are pretty much adding them together. So if I go to mix RGB, we are adding them together over, so you can kind of see like here, maybe something like that. So overlay chop, but that now that's just two normal maps on top of each other. So what we then need to do is take the other thing, which is the UV map. So a UV map of an object is essentially when we this is another thing well explained by a cube. If we have um come on. If we have a cube like this, if you've ever done origami or something, you can essentially unwrap a cube. Um, you can make a cube out of paper, and um, when we make models and then texture them, what we're eventually doing to put a texture on it is turning that 3D object into a 2D one. Why are those two separate? How strange. So to demonstrate this, there you go. So now I can make this. Let me just get the unwrap correct. Come on, Henry. There you go. That's the. Well, basically, we take this cube and unwrap it into this UV map down here. So we have each face. You can see each face go orange as I click them. And we're kind of unwrapping it like this. There you go. Unwrapping it like, and there you go. We've gone from a cube to a unwrapped cube to a piece of paper that's cut into like a cross shape and folded out. So once we've done that, we can actually use that to our advantage here. So we take our geometry now, plug it into our mapping node. We can now, if we want to say take a add will do. Oop. I don't think we want that. We want to plug our node into here, and we want to add. Oops. We want to add something onto our X and or Y position. So X and Y is the equivalent of I forget which way around it goes, but like U and V. It might be the opposite way around. So this directly translates into X and Y. So we can then take this mapping node and change the value. Let me actually to demonstrate my point further, take that and have separate mapping nodes and let's plug one in there and a separate one. The way we have this in the water shader, it's kind of hard to show, but maybe I can do something like, oops, to kind of show what I mean. No, it doesn't work very well. Well, there's definitely a way of showing it, but you scroll the UVs along like this, and if you have two of them going in opposite directions, you can essentially oh yeah, that'd be fine. So if you have one going this way, let me yeah, that's how you do it in Blender. I've done it in obviously I've done it in Unity, but in Blender this would probably be the next best way. So here we're taking XYZ to RGB, because really we don't want to be scrolling the texture in all axes. We just want to be scrolling it in a separate axis each. So if we take a math and times this by -1, hopefully we can get it going in the opposite direction. So we take a Y, plug it in there, and we take Y, plug it into the same spot. Oops. Yeah, no, that's not gonna work. Take Y, have an add value, and pretty much the same thing here. Let's try it. Stick. See what happens. Basically, oh, hasn't worked too well. But basically, once you get two UV maps scrolling against each other successfully, you get quite a nice wave texture, which is what we have here. Except with this one, it's using Unity's shader graph, and we have a little bit more depth as well using the screen's position. But this is also pretty much available on Unity's website. They show you a good way of doing it. It also uses a little bit of gradient noise and random noise to change the vertex position as well. So here we are changing the mesh as well as the normals of the mesh. And it creates this quite nice water effect. So that's the acid. Just as an extra effect, we have little bubbles rising up from the acid, which is just a particle system with some green bubbles emitting from it. And we also have some props just floating around. They'll float at runtime, but not at edit time. Little skulls and bones, just to add a little extra effect. we also have these lovely buildings, which are interior mapping. So if I go into wireframe mode, that doesn't really help much. Shaded wireframe mode, you can see that each one of these buildings are just cubes. They are not complex, they don't have detailed interiors or anything like that. They're just cubes. All they have are these blue. They're just flat cubes. The only thing that's special about them is they have interior mapping, which is to say a cube map, which is what we'd use for skyboxes, um, inside of each little section of the building. So let's open up that shader. And we actually have more than one to add some variety in. So we have multiple cube maps, some of them with just like chairs and windows, and others with like a carpet or like a table or a door. The ones further away, a TV at the end. These are actually rendered by me in Blender as well, so I created all of these rooms in Blender and turned them in. Things like chairs, 3D things don't work too well. But that door back there works fantastically, and the lights work too. Um, so all the lights reflect the clock is okay. They work really quite well. And the way it literally uses just like a cube map inside of a texture. Let's open this up and have a better look. Right. So interior mapping. So we first off start off by dividing that one big face into a load of little faces, so we have all the rooms. We are taking the view direction and doing some fun maths onto it. Just multiplying, adding the view direction, splitting, and getting the normal so that they look roughly okay. So this view direction multiplier really is the key. It's essentially just a lot of fun little maths on top of adding view directions to cube maps to create this sort of effect. And Shark Mob's Vampire the Masquerade Blood Hunt recently used it really well to create Central Prague. All of those buildings are likely to be interior mapped. You can't go inside them, but you can see all of them inside all of them, and it's a very nice effect. So that's what we've used for these buildings, and I think I've used them also in one of these scenes, just to add a little bit more of an effect. So yeah, there you go. Just to make it seem more like a place that kind of, obviously this isn't a place that exists, but you could imagine some windows and some offices or something in an area like this. The third shader, let's go over the skin shader. So when the player takes damage, you might notice their skin seems to just disappear, you know? Just has a little bit of a meltdown. Ooh. So you can see the skin started to fade away, so you get a little bit of muscle and you get the bone. That is scary as hell. I didn't even realize that AI would do that. I didn't expect that at all. That was some genuinely frightening stuff.
Hey, congratulations, you made.
So, yeah, when you take a little bit of a bath, your skin's gonna start melting horrifically. So let's have a look at that how that shader works. Um, do, do, do. So the way it works, so it takes this gradient noise, starts off by gradient noising, and actually the first thing it does is step through this texture. So we have this muscle texture, and it takes a step from health. So health is a, a, a float that I've introduced here, and we changed this health through script in the player controller to take damage. Um, so we'll do a quick apply effects. Do, and somewhere around here we change the health value. It's probably in the health bar or something. Um, but yeah, we basically changed the health value, and that steps through um, a blend to change the texture using the normal, using, sorry, not the normal, this gradient noise and combined with a Voronoi. So Voronoi is both a gradient noise and a Voronoi actually are randomly, well, mathematically generated textures. Again, maybe nice to show it here. So I can add in a Voronoi texture and stick it into color, and then I get this lovely kind of almost glass, stained glass effect. And Unity has this as well. It's quite a common function. It's very useful because when we combine it with stuff like gradient noise, I'm not sure if uh, let's see if we can RGB uh, to get a similar kind of effect. Maybe? Not really. Not entirely what. This it'd probably just be noise. Um, so combining these two, we get a little bit of a bumpy, little bit of a textured um, Voronoi, which really helps to bring the texture through when it comes to melting skin, I guess. Let's bring this back. So yeah, if it was just noise or just Voronoi, it'd be pretty obviously like, well, it's unnatural, but pretty obviously like fake, even though again it's a video game. It's very obviously fake, but it just doesn't look right. It looks too clean, too perfect. So you combine a bit of them, multiply them together, and we're stepping through a value to adjust the strength of the Voronoi and gradient noise. Um, we take this skin texture combined with the muscle texture and the normal map and everything, and we're just blending them together along with the alpha is important. We're basically lerping from 0 to 1 because or sorry, I've adjusted it slightly just to make it look a little bit better, but um, in here alpha we can adjust the alpha of objects. I believe it's black being fully transparent and white being fully opaque. So if we take the alpha from this gradient and Voronoi noise, um, and because it's black and white, we can use that along with the steps so it's like properly in line with everything. into the alpha channel, and that means when we adjust health, so maybe if I do that, it kind of fades in and fades out, and it takes, instead of instantly going from totally opaque to totally transparent, using that step node really helps. Um, so yeah, that's pretty much how the skin texture works. It's a quite nice effect. I've also added some bones underneath, and they share the animation with the arms. So once your arms are like almost dissolved, you can still see something, even though it's very gruesome. Um, the last shader that we use, I believe, uh, unless one of the team has gone behind my back and secretly made some shaders without my knowledge, is the cloud shader just for the first level. Uh, it gets the point across. I'll put it that way. It's similar to the water texture where we're scrolling two normal maps across each other to create a sort of cloud effect overhead. Um, it just it looks alright, but it's not like realistic or anything. It's closer to like the old Quake clouds if you've ever seen those. We could bump the speed up and make them go like really fast if we wanted to. That'd be quite funny. Let's see if we can do that for a laugh. Speed, speed, speed. Where is it gone? Oh my. Yeah, it gets pretty trippy. Uh, that was not quite what I was looking for. This, essentially, both this and the water texture adjusts the cloud over time. So here we have this time node. Oh, I did have it. Small cloud speed. Oh, it's right there. Um, so yeah, we can make them a lot faster if we want. Oh, that's not quite. There you go. Not quite. Let's try and make it go as fast as possible. There you go. That's pretty fast. Pretty trippy. But yeah, those are the clouds. The light shafts are a combination of they are a mesh, so they're literally just a mesh with a um with a little kind of sun ray effect. It's not that complex. It's just time um combined with a little bit of Voronoi and a little bit of opacity and alpha to create the effect, and also a uh, particle system that just generates quite slow, relaxed. I'm getting hunted down. Um, like little shafts of light. I think that's a pretty good end to the video so far. Sorry, it's a bit of a long one, but a lot of these effects took a lot of time to do, and it's worth talking about. They're quite fun to make. Shader Graph is a lot of fun, as is just materials in general. It adds a lot to your game as well, so it's all in good fun. Thanks for your time. If you have any questions, feel free to comment or send me a message. And I'd love to explain in more detail if there is enough people who would like that. And enough people for me would be like one person. So let me know. Thanks for listening and have a nice rest of your day.